Hey guys, how are you all? Today we are going to discuss about amines, physical and chemical properties. Physical and chemical properties, right? So first the physical property. The lower the aliphatic amine are gases and fizzy odor. Okay, so primary amine with 3 or more carbon atom are liquid, still higher ones are solid. Okay, so lower number, so say for example methylamine, ethylamine, propylamine. Okay, this 3 is liquid. Okay, higher than that, if I am taking the butylamine, pentylamine, hexylamine, then it is become a solid. It is become a solid. Clear? Right. Next, aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. Okay, so if your amine is exposed to oxygen, at the time it become a colored one. It become a colored one. Am I right? So first 3, say for example methylamine, ethylamine, propylamine is liquid. Okay, so butylamine, pentylamine, hexylamines are when we more than 3, if you go for more than 3 carbon, your amine going to be solid. Clear? Right. So lower aliphatic amines are soluble in water because they can form the hydrogen bond with water. However, the solubility decreases with the increase in molar mass of the amine due to increase in size of the hydrophobic group. Say for example, this is your NH2, right? So this is 1 carbon, then 2 carbon, then 3 carbon, then 4 carbon. Okay, at the time what is going to happen? The number of carbon get increases, right? At the time hydrophobic group get increases, right? So at the time the solubility, what will going to happen? Your solubility get decreases because this alkyl group is water eating. Okay, so this is hydrophobic one. It will not interact with water. Okay, it will eat the water. Okay, hate the water. Okay, so that is the reason why your alkyl group get the size get increases. The alkyl group size get increases at the time your solubility of amines get decreases, right? Next, higher amines are essentially soluble in water. Considering the electronegativity of nitrogen and amines and oxygen of alcohol, so you can predict that pattern of the solubility of amines and alcohol in water. So butane 1-ol and butane 1-amine, which will be more soluble in water. Why? Okay, so amines are soluble in organic solvent like alcohol, ether, benzene. You may remember that the alcohols are more polar in amines, form the stronger intermolecular hydrogen bond. Okay, so the primary and secondary amines are engaged in intermolecular association due to hydrogen bonding. Okay, so nitrogen of one and hydrogen of another molecule. So the intermolecular association is more in primary amine. Secondary amine, there are 2 hydrogen atom available in case of bond formation in the primary amine. The tertiary amine do not have the intermolecular association, absence of hydrogen, right? So atom available for hydrogen bond formation. Therefore, the order of boiling point. So in this table which is given for you, okay, in this table which is given for you, look here. So look here, this is, I want to explain to you, this is your primary amine. Okay, this primary amine which has the more association because nitrogen which has 2 hydrogen in case of primary amine. In case of secondary amine, nitrogen has 1 hydrogen. In case of tertiary amine, which has 3 alkyl group in the nitrogen. Clear? So this become a primary, this become a secondary, this become a tertiary, right? So if you take the primary amine which has the 2 nitrogen and the hydrogen bond, right? 2 hydrogen and the nitrogen bond, right? At the time the more association possible in the primary amine, right? But in case of secondary amine, we have only nitrogen only 1 bond, right? So here there is no bond, right? So your association going to be, your molecular association going to be more in case of primary. Okay, then more in case of primary, then secondary, then only tertiary. The tertiary there is no hydrogen bond association. Clear? Right. So the boiling point of amines and alcohol alkane almost same. So molar mass of shown in table 13.2. Okay, so next we go for the comparison. Okay, we are going to comparing. Okay, so this is your first molecule, this is your primary amine, this is your secondary amine, this is your tertiary amine. Okay, so this is also tertiary amine, this is your alcohol. So alcohol, as I told you already, if you are taking the nitrogen and hydrogen, if you are taking the oxygen and hydrogen, which one going to be more polar? Your oxygen one going to be more polar, because we know that the oxygen electronegativity 3.5, the hydrogen electronegativity 2.1, the difference going to be 1.4. But in case of nitrogen and hydrogen, the nitrogen is 3.0 electronegativity. In case of hydrogen 2.1, your difference going to be 0.9, whereas the electronegativity difference is more. Oxygen and hydrogen is more. Okay, so at the time your polarity also more. At the time it is able to make the strong hydrogen bond. If it your strong hydrogen bond means your boiling point going to be more. Understood, right? Fine. Okay, so this is your primary amine, this is your secondary amine, these two tertiary amine. As I told you already, the primary amine, the hydrogen bond, okay, the intermolecular association is more, right? Okay. When it comes to chemical reaction, very interesting one. Okay, the chemical reaction, because of we take the nitrogen. So nitrogen is 15th group, right? So 15th group means how many valence electron? It is going to be 5 valence electron. So if I take the 5 valence electron, 3 valence electron involved in the bonding, right? 3 valence electron involved in the bonding. Rest of the 2 electron remain over the nitrogen, remain as a lone pair of electron. Okay, so you know, right, the lone pair of electron, how it's come over the nitrogen. Next we go for the hydrogen, right? So if you are going for the nitrogen bond, so there is electronic difference between the nitrogen and hydrogen, right? So the first reason, the reactivity of amine, the first reason is there is a lone pair of electron present over the nitrogen. Okay, what is the second reason? There is a electronegative difference between nitrogen and hydrogen. Okay, right? Akshay, are you watching this video? Amirta, are you watching this video? Okay, so if you are watching this video, just comment in the comment box. Okay, so look here, the difference in electronegativity between nitrogen and hydrogen atom and the presence of unpaired electron over the nitrogen makes amines reactive. The number of hydrogen atom, okay, attached with the nitrogen atom decide the course of the reaction. That is why the primary, secondary, tertiary in many reaction, okay, so differ in many reaction, okay, because we know that the 2 hydrogen, 1 hydrogen, 0 hydrogen. So moreover amine behaves a nucleophile due to presence of unsaid pair of electron. So some of the reaction which is given here. Okay, so this is lone pair of electron which is having it, which is act as a base, this is act as an acid, finally we will get the salt. Okay, this is acid, this is base, we will get the salt. So because we know that, right, this lone pair of electron abstract the proton, it become a NH3 plus, right? For the another slide. Okay, so look here, so the amine salt treatment is given. Okay, so we know that, right, in this the amine salt are soluble in water but insoluble in organic solvent. So this reaction is the basis for the separation of amine from the non-basic organic component. Okay, there is a amine is there, amine with non-basic compound. Okay, amine present, okay, in the non-basic compound. At the time, if I use the any acid, at the time your amine get react, right, at the time it become precipitate out. Okay, so like here this is your amine. Okay, there is a non-basic component is there. If I add the acid, at the time your amine react with your acid, form the precipitate. Okay, we can separate it, right? Okay, this is very important. Next we go for the reaction of amine with mineral acid, right, to form the ammonium salt. So that this basic in nature, amines have the unsaid pair of electron on nitrogen, due to which they behave as a Lewis acid. So this is Lewis acid. So is this Lewis acid or Lewis base? This is Lewis base. So water acts as a Lewis acid. So we'll get the base abstract the proton and become a conjugated acid. So this is become a conjugate base. Okay, so product by reactant, the concentration of product by reactant, we know that the K into H2O, it become a Kb. Then from Kb, how we are derive the pKb? This is the equation you might have studied in the equilibrium chapter 11th standard. Okay, so in this what they are trying to say is, if it pKa value and Ka value, okay, if it Ka value is higher, the pKa value should be lower. Okay, at the time your component going to be more basic in nature. Clear? So Ka value increases, basic character increases. Ka value increases, basic character increases. Okay, pKa value decreases, your basic character increases. Okay, this is the thing I want to tell you, okay, in this concept. Next, look here. So your methylamine is there, okay, your methylamine is there, okay, then your N-methyl methylamine is there, okay. So after that N, N dimethyl methylamine is there. So then we have ethanamine, okay. So your pKa value, what it going to happen? So in this case your pKb value is less for this 3.0. okay, this is going to be more basic. Okay, so this is going to be strongest base, but in case of this one it is going to be weakest base. Clear? Right. Next, look here. You find the discrepancy while trying to interpret the Kb value means on the basis of plus A and minus A effect of the substituent present in the amine. Okay, besides the inductive effect, there are other effects like solvation effect, steric hindrance, which affect the basic strength of amine. Okay, just to ponder over, we will tell you one by one. Okay, look here. First we are comparing the basic character. Okay, comparing the basic character of alkylamine and ammonia. Okay, so let us consider the alkyl and ammonia. So if I take the ammonia, in that only the 3 hydrogen is present here, but if I am taking the alkylamine, what will going to happen? It is going to be CH3NH2. So this CH3 will release the electron to the nitrogen. The electron density get increases at the time your electron availability get increases. It acts as a more basic compared to your ammonia. Okay, so due to electron releasing nature of your alkyl group, the pushes the electron towards the nitrogen, thus make the unshared pair of electron pair is more available for sharing for the protonation of the acid. Okay, moreover the substituted ammonium ion formed from amine get stabilized, okay, due to dispersal of the positive charge by plus A effect. Okay, so alkyl group, hence the alkylamine are stronger base than ammonia. Thus, the basic nature of aliphatic amine should increases with increase in number of alkyl group, right? The basic character should be increased if you increase the number of electron releasing group. Am I right? So this is you are going to be your primary amine, only one electron releasing group. In case if I am taking the secondary amine, at the time 2 electron releasing group is there. If I am taking the tertiary amine, at the time 3 electron releasing group is there. At the time your basicity get increases, right? Yes, it is get increases. The tertiary amine is more basic than secondary amine, then primary amine. Okay, but in case of this is in the gaseous state, all amine in the gaseous state. But in case if it present in the liquid state, the trend get varied, because here only the plus inductive effect play the role in case of gas. But in case if it comes to liquid, at the time 2 other factor also playing the role. The first factor, it is going to be your salvation effect. Okay, the second factor, it is going to be steric hindrance. Okay, so salvation effect, steric hindrance, which is playing role in the liquid state, but in case of gaseous state it will not play the role. So in gaseous state only one role it is there, that is inductive effect. Okay, understand? Right. Okay, the trend is not regular in the aqueous space. Am I right? So the substituted ammonium cation gets stabilized not only by the electron releasing effect of alkyl group, but also by the salvation of water molecule. So greater the size of the ion, lesser will be the salvation. So less stabilized is the ion. So the order of stability of your nitrogen substitute, okay, your amines, it is going to be primary is more stable than secondary than tertiary. Clear? So if it only salvation effect is there, your primary amine is going to be more basic, but combined effect, one more, that is your what? That is your steric hindrance. Okay, so look here, the steric hindrance, we are going to look into it. The greater the stability of substituted ammonium cation, the stronger should be the corresponding amine. So thus the order of basicity is, the primary is more basic compared to your secondary and tertiary. But there is other factor also playing a role, right? Secondly, when alkyl group is small, the CH3 group is there is no steric hindrance, hydrogen bonding. Okay, in case of alkyl group bigger, then CH3, there will be the steric hindrance of hydrogen bonding. Okay, so therefore the change in nature of the alkyl group, so CH3 through C2H5 result in the change of the order of the basic strength. So there is a subtle interplay of inductive effect and salvation effect, steric hindrance of alkyl group, which decides the basic strength of the alkylamine in aqueous state. The order of basic strength in case of methyl substituted amines and the ethyl substituted amine, it is there. So this is your secondary amine. So secondary amine is more basic compared to your tertiary amine because of in tertiary amine there is a steric hindrance. There is a steric hindrance. That is the reason why your tertiary amine is less basic compared to your secondary amine. Then primary amine, then ammonia. But in case of methylamine at the time, again the tertiary amine is the least basic compared to secondary and tertiary amine. So this order due to because of not only your inductive effect but also the salvation and steric hindrance. One more thing we have to discuss. Okay, what is that? That alkylamine and your aniline. Okay, alkylamine and aniline. This here you can understand only two things. Okay, say for example, if I am taking the NH2, okay, this lone pair of electron localized here, it will not move anywhere. Okay, but in case if it lone pair of electron present over the nitrogen, but that nitrogen is bonded with your sp2 iodized carbon of aromatic ring, at the time this lone pair of electron undergo the delocalization, this lone pair of electron not available for your protonation. Due to that, your alkylamine, your ammonia is going to be more basic. Okay, your alkylamine ammonia is more basic compared to your arylamine because the nitrogen, okay, nitrogen bonded with the sp2 iodized carbon of, okay, benzene ring. Okay, so this lone pair of electron undergo the delocalization. So this lone pair of electron not available for the protonation. If it not abstract the proton, that is not considered as a basic, right? Clear? Right. So next, one more thing I want to explain to is in case in your amine, okay, in your amine, if aromatic amine you can take it. This is your aromatic amine, right? In this, if it electron releasing group like OCH3 come, at the time your basic character get increases. Electron releasing group increase the basicity. Electron releasing group increase the basicity. Okay, but in case electron withdrawing group is come, at the time your basic character get decreases. Clear? For the one more thing here, we need to solve this question, right? So as I told you, so this is your secondary amine, primary amine, ammonia, this is arylamine. So arylamine, the lone pair of electron is not available for protonation. This is going to be least basic. As I told you already, this is secondary amine is more basic than primary. So ammonia is another one. Okay. So there is a alkylation which is there, right? So alkylation, what is alkylation? If I take the RNH2, okay, so RNH2, alkylation reaction, I will write it in a detailed way. Okay. Look here, RNH. Alkylation, right? I will take the alkyl group. Okay, so what will going to happen? This get, okay, not this one, this and this HCl. Okay, so it eliminated as HCl, then there is a formation of RNHCH3. Clear? Understand? Okay, next to go for the acylation. Okay, next we go for the acylation. So aliphatic and aromatic primary amine. Okay, aliphatic and aromatic primary and secondary amine react with your acid chloride and anhydride ester by nucleophilic substitution reaction. Why? We know that, right? In the amine there is a presence of lone pair of electron. I told you what is nucleophile? Electron rich species, or if it negatively charged one. Okay, if it has lone pair of electron, we can say electron rich species, so it acts as a nucleophile. Okay, so you can consider the reaction as a replacement of hydrogen atom. Okay, NH to NH. So the group by acyl group, the product is obtained by acylation reaction are known as amide. Okay, the reaction is carried out in presence of base stronger than amine. Okay, like pyridine, which remove the HCl, so formed is shift equilibrium to right hand side. Okay, so here look here. So this is your acetyl group. We know that, right? In this Cl, this hydrogen get removed means at the time the NH bond with C double bond O. Okay, this is your product. Here also the hydrogen again bond with Cl. Okay, so we know that, right? This nitrogen going to bond with C double bond of CH3. Next we go for the your benzenamine in that hydrogen, and this is there. Okay, so the C double bond of CH3 connect with nitrogen. Clear? Right. Here there is a amine is there. Okay, so CH3, NH, then Cl, C double bond O, pH. Okay, so HCl get removed, then there is a formation of NH, C double bond O and pH. Understand? This is acylation reaction. Okay, this is benzyl, right? So this is benzyl. But before that we discussed only acylation reaction. Okay, so next reaction it is there for you. Look here, the next reaction is the carbolamine reaction, right? This carbolamine reaction, aliphatic aromatic amines on heating with chloroform. So we will get the ethanolic potassium hydroxide and isocyanide carbolamine, which is foul in smell, foul smell, that is not sweet smell. Okay, that is foul smell in case when your primary amine react with chloroform and potassium hydroxide. This reaction is known as carbolamine reaction or isocyanide test. Okay, so in case in your lab, in your compound is amine. Okay, in your if your compound, the given component. Okay, so if you are going to lab, they are giving some chemical substance, they are asking to find out the chemical compound, whether it's alcohol, ester, or amines, or any other substance. Okay, so at the time we can use the carbolamine test in order to prove the presence of your component. Okay, in that the amine is there, right? Okay, next we go for the reaction with nitrous acid. Okay, look here. So here is the reaction with nitrous acid. So if I am taking the alkyl amine, at the time there is a formation of diazonium chloride. Okay, this alkyl diazonium chloride is not stable. Okay, so it can be break down into alcohol, nitrogen gas and HCl. Okay, this is very important reaction. Why? Say for example, if you are taking the protein, if you are taking the amines, we know that, right, there is a presence of nitrogen. Okay, this presence of nitrogen estimation, okay, this estimation we are following this reaction only. Okay, but in case of aromatic amine, when it reacts with nitrous acid and HCl, at the time there is a formation of benzene diazonium chloride, but here this diazonium chloride is stable. So diazonium chloride, okay, diazonium chloride is stable when electron withdrawing group is there. Okay, so this is minus A effect is there, right? So N2 gets stabilized by minus A effect. But in case the same time, if it plus A effect is there, this is not going to be stabilized. Okay, so plus A effect will not stabilize the diazonium salt, but in case of minus A effect stabilize the diazonium salt. Okay, right. Next we go for the reaction with your sulfonyl chloride. Okay, this is for the distinguishing of primary, secondary, tertiary amine. Okay, as this like this. Okay, I told you in the alcohol phenyl ether, how to distinguish the primary, secondary, tertiary alcohol. What is the reagent we used? Okay, if you know that, you can comment it. Okay, so your benzyl chloride, okay, also known as Innsbruck reagent, react with the primary and the secondary amine to form the sulfonamide. Okay, to form the sulfonamide, the reaction of benzene sulfonyl chloride with primary amine, which yield the N-ethyl benzene sulfonyl chloride. Okay, so here the chlorine, this hydrogen, it removed as HCl. So this is N-ethyl benzene sulfonyl. Okay, benzene sulfonyl amide. Okay, so here there is a presence of two hydrogen, right? Okay, after the reaction in your product there is a hydrogen is there. This can make the hydrogen bond, it can be dissolved in the alkali. Okay, but in case of if I am taking the secondary amine, at the time this HCl get removed. Okay, so this is HCl, so we can get the N, N diethyl benzene sulfonamide, but this product is not soluble in the your alkaline. Okay, not soluble in the your alkaline. Okay, because this compound not able to do the hydrogen bond with your alkaline. Okay, so next we go for the your tertiary amine. Okay, So if I'm taking the benzene sulfonyl chloride, this benzene sulfonyl chloride with your tertiary amine at the time this nitrogen not having any hydrogen, right? So if it not having any hydrogen, this is going to be no reaction. So primary amine which form the salt, okay, which form the compound, which form the insoluble product, okay, that is soluble in the your alkali, okay. So primary amine form the product soluble in alkali, okay. Secondary amine form the product, okay, so form the product but that is not soluble in the alkali. But in case of tertiary amine, okay, it will not form the product, okay, clear? So I will stop here, okay. Any doubt it is there, you can comment it, okay. For that I will make this short video for that, okay. So thank you all watching this video. Do like the video, okay, share the video, okay. Any doubt it is there, you can comment it, okay. So till the time, bye bye, take care, do well in exam.